topic we have today is chemical bond. It will be taken by my humble self, Olukoya Olubenga. First of all, I was supposed to say, what is bonding? What do you understand by bonding? Bonding takes place between atoms or elements that are trying to reach stability of the octet structures of noble gases. Noble gases are known to have octet and duplex structure. So the intention of most bonds or most atoms and elements is to reach that stable electronic configuration. So why do atoms bond? Number one, atoms bond because of stability. They want to reach stability like that of the noble gases. They also want to what? To have polarity. And also the bonding of atoms also help us to understand the configuration and the shapes of molecules and compounds. So the two major bonding process is electrovalent bond and covalent bond. In electrovalent bond, also known as ionic bond, it involves the sharing of electrons from one atom to another. From one atom to another. There is transfer of electrons from one atom to another. We all know that in chemical reaction, electrons play a major role in the behavior of atoms. So, electrons are transferred from the donor atom to the acceptor atom. So, this is what happens in ionic bonding. In covalent bonding, there's also what? Electron sharing. Previously, talking about the electrovalent bonding, there is bonding, basically it is common between metals and non-metals. So when you look at what? Covalent bonding is the sharing of electrons between two atoms of the same element or different element, exemplified by water molecule here. Looking at this water molecule, you see that it is between hydrogen and oxygen. Oxygen needed 2 more electrons to complete its octet structure, while hydrogen had only 1 electron. That is why you see a situation whereby the hydrogen atom is combining with the oxygen atom and they share 1 electron to complete the octet structure for oxygen and duplex structure for hydrogen. Other bonding type that's common is also metallic bond. Basically, metallic bond is a type of bond in which there is a central positive charge with sea of electron around it. There is delocalization of electrons around the metallic bonds. Always it is common between metals, which you can see in metal lattice. Understand? We'll still dwell on it later. We'll talk more on metallic bonding. But one major thing you need to understand about metals is that metals have their characteristic properties and the kind of bonding they go through. Then, from what we are seeing here, you can see the differences between the covalent bond and electrovalent bond. Obviously, the electrovalent bond, it is a bond between atoms of these different elements. One is acting as a donor, one is acting as the acceptor. The covalent bond basically are bonds that are formed due to electron sharing between two atoms, common in non-metals. A type of electrostatic attraction exists between atoms in electrovalent bond, while a direct chemical bond between atoms occurs in covalent bond occurs between atoms in covalent bond. So the difference in electronegativity value determines the strength of the electronegative atom, while the difference in the electronegative value of atoms is lower than a specific value of 1.7 in covalent compound. So ions basically are involved in bond formation, electrovalent bonding, while atoms are involved in what? In bonding formation in covalent bonding. So still trying to compare the different uh, between ionic bond and what? Covalent bond. You see that there is no much to, there is a difference between them actually. That is metallic bonding and ionic what? Ionic bonding. So one basic thing you need to look at that there is no influence on the strength of the bond of what? Metallic bond by any the ions involved in the process of bonding, unlike what? Ionic bonding, which is influenced by what? The different elements involved in the bonding process. One major thing you need to also know about the properties of covalent bond and electrovalent bond is that they have compounds formed. Compounds are formed as a result of this element. A very good example of the covalent an electrovalent compound is sodium chloride, magnesium chloride. All these are what? Ionic compounds. But when you look at covalent compounds, such as the mostly polar solvents, like ethylene and all these other substances, trichylomethane, tetrachlomethane, all these are what? Are polar substances. So they have characteristics that is, in physical characteristics that is what? That you can use to describe them. When you look at ionic bonds, they are soluble in what? Soluble in water. They are soluble in water. They form electrolytes in solution. That is why they are used as what? As conductor of what? Electricity. This does not the same thing about what? Covalent bond compounds, which are, they are not actually soluble in water. So remember we made mention of configuration of compounds. So bonding helps for molecules to form shapes because of when you are arranging the electrons, electrons usually move in pairs. So the rearrangement of the electrons gives room or gives way for the formation of what? The bonding shapes. So the orientation they form makes them to form different what? Shapes. BeCl2 is beryllium chloride. That's a linear shape with a bond angle of 180 degrees. 180 degrees. So BF3 is what? Trigonal planar with a bond angle of 120 degrees. CH4 is tetrahedral with a bond angle of 109.5 degrees. Ammonia NH3 is pyramidal with a bond angle of 107 degrees. PH3 also has a bond angle of 107 degrees. Why? CO2 has a bond of 180 degrees with a linear molecule. All these as a result of the symmetrical and non-symmetrical arrangement of what? Of electrons. Understand? So we have other bonding types, just like we say, is metallic bonds, hydrogen bonds, weak van der Waals bonds, dipole-dipole interactions, and so on and so forth. So you see, by way of trying to digress from the concept of bonding, you look at it about, okay, what's this concept? Right? How does this apply to everyday life? Well, in everyday life, you do see buildings. Buildings are made from bricks, and these bricks are glued together with some materials. We tend to bond them together. Some we call adhesive, some we call abrasive, some we call different names. But they are these materials make the building to be what? To be very, very strong. So other materials that you come in contact with everyday life that is as a result of bonding process is batteries. Batteries are used in what? In cars. They are used in your torchlight. They are used in your phone. They are used in your cell phone. These are what? These are bonding electrolytes. Electrolytes that come and bonding. You see, your lead acid accumulate, a very common material that is used for what? Used as an application of what? Bonding process. So you see various bond angle, linear molecule from CO2. You have trigonal power for BF3. You have lone pair bond pair repulsion leading to angular bonding in what? In water. You have PF6. Understand? That's phosphorus 6 fluoride. You have tetrahedral structure in chlorine. You have trigonal pyramidal structure in BF5, and 107 in ammonia molecule. These are structures. So you can see electron transfer in sodium to fluorine, forming sodium fluoride. Sodium becomes positively charged and fluorine negatively charged. So we can see this now going back to our intermolecular forces. Intermolecular forces basically exist between molecules, and they are known as intermolecular forces. That is, forces that exist is known as intermolecular forces. So these forces are much weaker than in electrovalent. They are weaker than electrovalent compounds and covalent compounds. These forces are dipole-dipole interaction, weak van der Waals forces, and we also have what? Hydrogen. So example of dipole-dipole interaction, this one occurs this as a result of non-symmetrical arrangement of electrons and non-symmetrical arrangement of distribution of electrons within a molecule. This asymmetric arrangement causes formation of partial dipoles at both ends, leading to permanent dipoles. So the diagram shows a Lewis distribution. There's a diagram at the end of the slide that shows a Lewis distribution of electron in trichloromethane. Understand? This explains the forces holding together the polar molecules such as trichloromethane, and that's the reason they are polar, so because there's partial distribution of electron, unequal distribution of electron between the two ends of the poles, so leading to permanent dipole. Another example of van der Waals forces, the weak van der Waals force is also they are non-polar bonds. Because of the weak van der Waals forces, this explains the forces in non-polar molecules because of non-existence of permanent dipoles. So short-range forces, they are short-range forces of attraction, independent of bonding forces found in real gases at low temperature and high pressure. It is atoms, and it is found in between atoms. So van der Waals forces are also found in graphite layers. Ice, it is responsible for the behavior of ice, which makes it to melt easily. Iodine, solid, changing to gas without the liquid phase because of the presence of van der Waals forces. The last one is hydrogen bond. It is a strong dipole-dipole attraction which occurs between the hydrogen atom, which is strongly attached to a electronegative atom. So and it can also be found as a result of attachment to strong electronegative atom with lone pairs of electrons. So on the next slide, you can see the hydrogen bond. You see there is an attachment of the hydrogen molecule, an attachment of the hydrogen atom to an electronegative atom, despite the fact that you have a covalent bonding that exists between the oxygen and hydrogen atom, which forms a dipole pole. Then you can see the water molecule there. You see the hydrogen bond. The hydrogen bond causes the water molecule to have a high boiling point. So as I said earlier, I said I will make mention of the bonding. They're talking about the dipole-dipole interaction. So you can see between trichlorometry molecules, you see distribution of electrons between chlorine and carbon. You see uneven distribution. So more of the electrons are towards it. So therefore, creating a permanent dipole, leading to the formation of partial positive and partial negative side on the atom. And this is the reason why the element this molecule is polar in solution. So bonding has gone a long way, to our understanding of bonding makes us to understand how electrons behave in solution. So if you have an understanding of what bonding is, you will be able to know how to group elements. You can even be able to write chemical reactions. You can be able to know the stoichiometry of reactions. Thank you for listening.